So generically, what do we have? Again, going back, this habit that we have to have. We've been given a mouth, which is a line. Contextually, he exists here, right? But we know that really what we're going to be playing with is step one is going to be, if we follow the model from before, is grab this guy, right? So step one, select the mouth curve, or in this case, line. And now really is where the bulk of the algorithms comes in, because we know, roughly speaking, that we have to have something come out the back in the very long term that looks like a smile. We know that. But in the meantime, we've loaded the idea of something that kind of looks like this, right? That spatially, the reason we've drawn it this way is because spatially the new smile, the curve, is relatively speaking in the same place as the original one, which means that relatively speaking it will be in the right place for everybody else over here. But now we have to ask the question is how do we quantitatively define this guy and his relative setting out to everybody else? Before we had talked about doing something fancy where we said, fancy, logical, that says that guy is a curve, but a curve is infinite points, yeah? So we said, well, maybe we could just get this point and this point, and we've done something before where we grab this point too, but we had done this before, but in this case, any amount of these infinite points along that line will not give us a curve that looks like this. Equally, what type of a curve is this guy? Is this guy a NURBS curve, a spline curve? What is he? Is he a 3-point arc? We have to make that decision now on paper before we go forward. Now, we're already playing with points here. So let's just say, for instance, to keep it simple, that we try and select a 3-point arc as our main guy. So we know that's the final thing, which means our first business is how to take this guy right here, the mouth, select him, number one, and number two, create from him some 3 points that could eventually look somewhat like this. So let's take maybe a step two. Let's say we grab the 2 easy points. We always can get start and end points. We've already shown that. So let's say step 2 is get the end points of the line. Yeah? So then we have 2 points of 3. And then let's say, for instance, that those would end up being, in green here, those would end up being the end points of our final 3-point arc. Well, that makes it pretty simple then, yeah? Because then we just have to come up with one other point anywhere along this 3-point arc, yeah? That would give us the ability to create a 3-point arc. So we have the end points, and let's say we grab the middle point, yeah? Let's just say get midpoint of the line. That's great. So, but this point we would have had this, and this. Again, we talked about it. Those are still on a line. So what's the fourth thing we must do? Again, rough algorithm here. To get what we're after, we must be able to basically move this guy down to here, and then we might be able to do our 3-point arc and end up with this on the output. Yes. So the fourth statement is move the midpoint down. And that would be the rough algorithm that we would explore. Obviously, there's many ways to do this. So in this situation, we've chosen to go with the data that we're going to end up with is a 3-point arc. And the sacrificial data along the way are 3 points that we effectively extract/manipulate to get to being 3 useful points for us. So let's see how that works out for us if we go to Grasshopper now.